Today's video is part of a series of Precompile's proposals for the Ethereum Virtual Machine, or the EVM. A precompile is a native smart contract that lives at a known address. For example, the EC-Recover precompile lives at address 1. The precompiles that the EVM implements now do not have an associated bytecode, but are natively implemented in the Ethereum client in the language of that client. In a previous video, we showed a demo of our introspection precompile proposal. Today, we are showing a demo of our IPFS precompile proposal. This will allow developers to save and retrieve content to and from IPFS. IPFS, or the InterPlanetary file system, is a decentralized storage protocol. And this precompile can be built in a standardized way to accommodate multiple decentralized storage protocols, but this is a future discussion. I have a dApp here with some of the functions exposed by the IPFS precompile, which lives at this address. So instead of considering the precompile as a single function in the way EC-Recovery is used by Solidity, we treat the precompile as any smart contract with multiple functions. We have MetaMask connected to a local Geth node, which runs a fork of Geth with an implementation of the IPFS proposal, and you can see the logs from the Geth node here. So now we can save anything we want on IPFS, but the command goes through a controlled environment, the EVM. This is the missing link between the EVM and a decentralized storage system. Now the chain has access to a proof created by itself that an IPFS hash indeed belongs to some file content. So let's write a message here and store it. So our message is turned to bytes, and then let's save it. I have added some logs in the Geth code, with what functions are called by their signature, the input, and the result. And we can already see that a file has been added to IPFS with this content identifier, which is the same as this one showed here by the dApp. This is the hexadecimal representation of the content identifier, and this is the base 58 representation. So we can take this and search for the file on the IPFS network. And I have a local IPFS node here, and we can paste the identifier and browse the file contents. And this is our message. But we can also see it on any public IPFS gateway. But we can also retrieve the same file through the EVM. The load by content identifier function from the IPFS precompile expects the content identifier in bytes. Then it gets the file from the network and outputs the contents of the file in bytes. This is the content in hex format, and we can transform this into a string format. And this is our initial message. This was a short initial demo on this topic, and there will be more to come. You just saw an IPFS precompile implemented in a fork of Go Ethereum, or Geth, soon to be proposed as an EIP if enough interest is shown. The IPFS contract becomes an oracle for information that comes from IPFS. And you can save and load information from IPFS, use immutable or named mutable files, perform caching and memoization on-chain. There are still issues that need to be solved related to data availability, pinning, and data expiration, but any chain that has a virtual machine will need an extension that allows it to create proofs and interact with decentralized storage systems that can hold a bigger data load than the chain.